All right, so today we're doing 1.4, subsets of lines and planes. First up, for our objectives, we're going to define and identify the subsets of lines and planes. So we've been doing subsets, but now we're looking at subsets of lines and planes. So still applying what we know. And then we're going to state and apply the separation postulate. So how lines are separated into different parts, how planes are separated into different parts. So first up is new vocabulary, half line. Okay, so it's a subset of a line consisting of all the points on a given side of a point, okay, on a line. And it's denoted, a half line like AB is denoted like this. So the thing is to notice about this, okay, AB, notice it has an open circle above the A. Okay, and that's because it doesn't include that point. It includes all the points on a given side of a point. So it does not include A, but it includes all the points on this side of A, okay, to the right. So think about a number line. When we were in algebra, when we're graphing on the number line and we want those numbers that are, let's say this is 4, we want the numbers that are greater than 4. We do that open circle and then, we draw our line to the right. And so this is x is greater than 4, but it's not equal to 4. It's kind of the same thing with this half line, right? We're starting at A, but we're not including A, just everything to the right of A that goes towards B. That's a half line. Okay, then we have a line separation postulate. So every point on a line divides the line into 3 disjoint sets or parts. Okay, so we're going to have one point. So the point, okay, is one of those sets, and then it has 2 half lines. So on this line, okay, if we look at point B, okay, it's going to divide, this is line separation, it's going to divide this line into 3 parts. We're going to have point B as one point, and then we're going to have the half line that starts at B, so I'm going to have this open circle, and goes towards C. So we're going to have half line BC, and I'm actually, maybe let me trace that in a different color. So I'm going to start at B, but I'm not including B, and it's going from B to C. Then I'm also going to have the half line that starts at B. Okay, so it starts at B and it goes the other direction towards A or D. So we could call this B, half line, so open circle, BA. Okay, because again, it's open. It doesn't include point B. Point B is separate all of itself. So a point on the line separates the line into 3 sections or sets. Okay, so 2 half lines and 1 point. So this is a half line. Okay, and this one over here is a half line. Gotta love this new vocabulary. Now, that is slightly different than array. Okay, so array is the union. Okay, we talked about unions. It's where things come together. So the union of a half line and its origin. So notice, it's kind of hard to tell here, that ray AB is denoted as, it would have like a closed circle on this end and then an arrow on the other end. So it starts at A and goes towards B. Okay, so the origin of the ray is also called the endpoint. This time is included. Okay, so the origin is included. All right, so I'm going to erase my work here for a minute, and we're going to talk about this line in terms of rays. And you could redraw this line, that's okay. But it said ray AB is equal to ray AC. So let's look at this. So we have AB is also equal to AC, okay, because both names indicate the same set of points. Okay, they both indicate the same set of points. Because the arrow means it goes on forever. So since it says B, AB, but there's an arrow here, AB is all of this forever. And AC is also all of this forever. Okay, in that direction. It just doesn't go the other direction. It does not include D. Okay, wonderful. So let's see here. Let me scroll on down. Doesn't want to let me scroll. So give me a second. There we go. Had to switch off to something else. All right, so now we're going to look at point P and this definition of between. Okay, so we have this definition of between here. All right, so it says point P is between R and S. So if you look at this line over here, this diagram, point P is indeed between point R and point S. And this is important, like this is an actual definition for you. It is denoted as R-P-S. So that is how we denote between. Okay, that is it. And, okay, it has to be if R, P, and S are collinear. So collinear is a word you've already learned. It means they're on the same line. And ray PR, so right here we have ray PR intersects ray PS. Well, where do those two things intersect? What do they have in common? Well, they have point P. So that's what this is saying. Okay, so this is this is like the rule of between again, right? So between is denoted as RPS, and we have to know that the ray PR intersects PS has to equal set P, okay, or point P. But that is the definition of between, because we're going to use that a lot. So point Q is not between R and S. And you're like, duh, right? Okay, I get that. Geometry is a lot of like, I know this. What and why are you telling me this? Okay, so I know that you know these things. It's very obvious that Q is not on the same line as line RS, but it is a matter of applying the new vocabulary and learning this new vocabulary and utilizing it. So learn it and apply it, okay? So we know point Q is not between R and S because Q, R, and S are not collinear. They're not on the same line. So in order to be between, all 3 points must be collinear and their intersection results in a common point. That's what this is saying, right? Their intersection results in a common point. So you can say that or you can write it in that set notation, either one. But we are going to be using the definition of between a lot, okay? So the definition, I'm going to write this here so you realize how important it is to maybe make a note card of this vocabulary word. So the definition of between is used to define other terms, several other terms, and you'll see some today. Okay. So let's look at example 1. It says show that R is not between points P and S. Okay, so let me again erase this. You could draw another line. I have the ability to erase, so it's kind of nice. So show that R is not between P and S. Well, clearly it is not, right? It's up here, P is down here, S is down here. So it clearly is not. But if we were to take this idea of writing this, okay, so we would want, because we want to know that R, like we're kind of checking if R is between. So we would say, okay, well, ray RP, what's the intersection of ray RP and ray RS? What does that equal? The intersection of ray RP intersection ray RS would equal, so let's think about this. So ray RP and ray RS, what would their intersection be? I want to take you back for just a minute and remind you that we learned, right, that even though this ray only went to P, because that arrow keeps going, it actually goes on for infinity. So where is the intersection of ray RP and ray RS? Well, it's ray RS still. It is not point R. That's what it would have to be, right? It would have to be point R in order to prove that it's between. It is not R. It is ray RS. So that's how we're showing that R is not between P and S. Okay. Another thing here, another vocabulary word that we have is opposite rays. So ray PR and ray PS are opposite rays if and only if P is between R and S. Okay, so again, I get to erase and look at this line. I would recommend you drawing yourself one. Okay, so they are opposite rays if and only if, right? If and only if P is between R and S. So, and this is with any line, but the middle point has to be between. So let's see. So P is here, R goes this way. So there's PR. Then we have P here, and S goes here. Excellent. Okay, so they're opposite, but here's the deal. P had to be between for them to be opposite rays. Okay. Okay. Another vocabulary word, which you should know, is a segment. Okay. Segments consist of 2 points and all the points in between them. Okay, so 2 points and all the points in between them. So we have segment RS is denoted by RS with just a line over it. Notice there's no arrows. You can put endpoints on it if you want. You actually do not have to. Okay. The big deal is with the half line that it's an open circle. If you don't put an endpoint dot, it won't be wrong, okay, unless it's a half line, and then it will be. Okay, so then also we can talk about this with segments with some set notation. So symbolically, segment RS is equal to point R and point S, right? So point R, point S. And it's the union, okay, and we could say of X such that R, anything in between here, and S. Okay, so the such that R and any point in between, or X such that X is R, X is anywhere between R and S. Man, if I could talk today. So anything in between S and R is included in there. So P would also be included in our segment. Okay, let me clear this and we'll move up some more. Okay, so we're going to do example 2 now. It says determine whether each statement is true or false and explain. Okay, so we have our number line up here that we're using. Well, I guess it has letters on it, not numbers, but still. Okay, so this first one, A. Notice this does not have the open circle, so this is a ray. This one has an open circle, so it's the half line. All right, so ray CD. Okay, so ray includes the C and goes to D but keeps going. And we want a union of ray CD and the half line CA. Okay, so C, it's an open circle, and then to A. Well, I didn't write. There we go. So what is the, oh, sorry, the intersection, not the union. You guys were probably asking me about that. So it says the intersection of these two equals point C. Do you agree with that? Do they have point C in common? No, they don't, right? This is false. And so we need to explain, all right? So you could say a couple different things. I would say point C is not part of half line CA. So make sure you draw that open circle, right? It is not part of half line CA. And then I'm actually going to write the true statement. So ray CD intersection half line CA is equal to an empty set. They don't have a point of intersection. They don't have anything that intersects. Nothing at all. Okay. So I'm going to erase again. This time we're saying ray CD. Okay, so I'm going to go back here. I'm going to include C, go on to D. Like I said, I like to draw the whole thing. Union half line CA. Okay, so it's a union this time, CA. Last time I said it was a union, but it wasn't. And it says that this is equal to line, right, because it has arrows on both ends. Oh, sorry, this was a half line. And this is a line. This is a half line because that open circle. Equals line AE. What do we think about that? That is absolutely true, because remember, the union is when we're combining everything. We're taking everything in CD, in ray CD, and in half line CA, and everything along here from A to E in both directions is included. So this one is true. That one is very true. Okay, and we would say this time we could say C is part of, I would say, ray CD, which also extends to E. Because it'd be different if there was a gap in there, in between there, but there's not. C is included on the other one. It's not included in the half line, but because it's in the ray, it is included. All right, last one. This one says ray BC. Okay, so ray BC. So I'm going to include my B and go this way. Intersection ray ED. So ray E to D equals segment EB. All right, what do you think about that one? Okay, this one is also true. Sorry, and I should have wrote segment up here to help you. Okay, this one is also true. The reason being is that B is an endpoint. So I'm going to write end PT for endpoint. E is also an endpoint. Right, because here we are. There's B and here's E. And all the points in between are included. So PTS is for points, BTN is between, are included. Because again, we're looking for an intersection. So where do they intersect, or where do they overlap? Okay, so that is true. Now, one thing to note here, I've got this box here that you kind of probably are fitting your stuff around. While ray BC and ray ED extend in opposite directions, they are not opposite rays because they don't have a common endpoint. Okay, you might highlight that. That is something that's important. In order to be opposites, they have to share an endpoint and go in the opposite direction. Okay, so what that's saying is they share an endpoint, and one goes to the right and the other goes to the left. That is opposite. If they go like this, those do not count as opposite, okay, because they do meet. So those are not opposite. Okay, I'm going to erase that little note so I have room for the next stuff. All right, so next up, we've got our plane separation postulate. Remember, we had a line separation postulate. So now with the plane separation postulate, we're talking about a plane. Every line in a plane divides the plane into 3 disjoint sets or parts. So one part is going to be the line. So if I look at this example, so this line right here, okay, is one part. And then I'm going to have 2 half planes. Okay, so we have one line and 2 half planes. So let's look at the definition here. We have a half line, now we have a half plane. So a half plane is a subset of a plane containing all the points, so it's all the points on a given side of the line. So if I was looking and say I can extend this on up here so I can really cut my plane in half. So remember, my line is one section, okay, one of my disjoint sets, and then I'm going to have this as a half plane. So to the bottom of the line, and then this piece over here is another half plane. So a line cut my plane into three parts, the line itself and what's on each side of the line. Okay, then we have the half plane's edge, and that's just the line itself that separates the plane. So this red line that we drew, that's the half plane's edge. It's the edge of the half plane. And we have opposite half planes, just like we had opposite rays. It's the two half planes within a plane separated by a common edge. So these are opposite half planes because the red line here, their edge, they have this in common. Okay, and so this is going to become more apparent like when we're looking at a plane, okay, and maybe it has two lines through it. Okay, and they want to say, well, this section up here is an opposite half plane to this section here. Nope, that's not true. They do not share a common edge. They have to share or be separated by a common edge to be half planes with one another. It's the two halves that make a whole, or the two parts, because it doesn't actually have to be in half. Okay, that's just what we call it. All right, let's keep trucking. So I'm going to erase these and we'll move on. Okay, so an angle is another subset of a plane that divides the plane into three disjoint subsets. Okay, so we've got this picture of a plane here, and we have an angle inside of it. So first of all, an angle is the union, see there's that vocabulary, of two rays with a common endpoint. So we have ray BC, we have ray BA, and their union together, we're putting them together at point B. So they have a common endpoint. So we can say angle, you're going to need to learn this symbol and use it all the time. So that's the other thing about geometry. I've told you that it's all vocabulary and learning it and using it. The other thing is learning how to denote these things with the symbols and what those symbols mean, because you will need that for the rest of your math career and being able to denote those things. Okay, so angle ABC is equal to ray BA union ray BC. Okay, that's just the way that you can write this without writing the words out. All right, then we have sides of an angle. The sides are just the two rays that form the angle. So here it's ray BA and ray BC. And we have a vertex of an angle. The vertex is the common endpoint or the origin. So B is your vertex, point B. Okay, so one thing about angle notation. This is very important as well. Okay, so we're going to use the symbol for angle. Okay, it looks kind of like a less than sign, but it comes down and then it's flat, okay, on the bottom to be an angle. But angle ABC or angle CBA are both correct. The point is on one side, the vertex has to be in the middle, and the point on the other side. It does not matter, but note, see how B is in the middle of both of these? That's because it's the vertex. So when we name an angle, it does not matter if you name it angle CBA or angle A, start at A, B, C. What does matter is that B is in the middle. Okay, that is the important part. The other thing is we can name them. So notice there's three letters here. So it's endpoint, vertex, endpoint. You can also name them with just one letter or sometimes a number, and that can be used when it couldn't name more than one angle. All right, so here there's only one angle B here, so that can be called angle B. But if I had this combined, okay, so here's A, B, C, D. I can no longer call this angle B because angle B could be from angle A or endpoint A to B to C. It could be A to B to D, or it could be D to B to C. There's actually 3 angles in there, so we can no longer call it angle B. If there were numbers in here, so this is 1 and this is 2, then we could call this angle here angle 1, because no other angle could be angle 1. And we could call this one here from C to B to D angle 2, because there's no other place for angle 2. But angle, the big one, you have to call angle A, B, D, okay, because you can't call it angle B. So hopefully that is clear. Then we have the interior of an angle. Okay, so the interior of an angle is the intersection of the 2 half planes determined by the sides of the angle and containing points from the other side of the angle. So you're probably like, what? Okay, and this picture kind of shows it, but let me show it to you a little easier. So what it's saying, it's the intersection, so there's vocabulary, of the 2 half planes. All right, so we've got this half line here, okay, and they put a dotted line across there, but that's one half line. And so, so that everything down here is a half plane. Whoops. All right, then we have this other line that goes up through here. All right, and this is a half plane of that. Notice where they intersect. Okay, they intersect right in here. So this is the interior of your angle. That's all that's saying. That's the interior of your angle. And again, that's a definition where you're like, seriously? I already knew that was the interior of the angle, because interior means inside of the angle. Okay? It really is that simple. But geometry puts everything into words and definitions. So don't feel like it's super simple and you're overthinking it, because it is super simple. And that's okay. All right, then we have the exterior of an angle. So the exterior of the angle is obviously the outside, the exterior, or it's the complement of the union. Okay, so it's everything outside of it. So again, don't overthink it. Let's look at example 3 then. It says use the figure to list all other acceptable names for each angle. All right. So if we look at angle YWZ, so it's going from Y to W to Z. What other names could we give this angle? So could we call it angle 2? Because there's a 2 in between here, right? It's saying it's going, sometimes I will draw a lot of lines. It's like, okay, from this side of the angle to this side of the angle. That's angle 2. Yes, we can absolutely call it that. It has a W as a vertex. Can we call it angle W? No, because angle W could also be this angle. So this side all the way over to this side. So no, we cannot call it angle W. Remember, the other thing is instead of going from Y to W to Z, we could start here and call it angle ZWY. So can we call it angle ZWY? So could we name it angle WZY? WZY? No, because the vertex is not in the middle. The vertex has to be in the middle. All right, so again, I'm going to erase, and we're going to do the next one. Okay, so angle 1. What other names could we give angle 1? Well, angle 1 is in between these two rays, so we can start at x, so it's going to be angle x, w, y, angle x, w, y. Or we could start at the y endpoint and say it's y, w, x. So angle y, w, x. But again, the w is in the middle for both of them. It has to be in the middle because it is the vertex. It's the middle. It's the common point between those two rays. Okay, next up. How else could we name this last one? That's angle ZWX. So ZWX. How else can we name that one? Well, we can't give it a number because it's not angle 1. It's not angle 2. We don't get to add those together and call it angle 3. It's not happening. So how else could I name that? I can't name it W because W, again, could apply to this big giant one or either of these two little ones, so I can't call it angle W. Do I have any other options? Yes, I can reverse my letters, right? It can be angle X, W, Z. I could start at the X, go to my vertex, and then go to the other endpoint of the ray, or the other end of the ray. And again, my vertex has to be in the middle. You're probably tired of hearing that. All right, I will see you in class. Have a great day.